Hello everyone, welcome to this episode of Geospatial Solutions Training brought to you by DJI Enterprise. This is Ron Lee from Solutions Engineering Team, and in this episode I will cover real-time kinematic, or mostly known as RTK. Let's have a look at the training content for this episode. First, I'll be covering the accuracy of the drone as well as its data when it's under standard GNSS positioning mode. Then talk about the difference when the drone is connected to real-time kinematic for positioning and how the accuracy of the data compare with the standard GNSS positioning. After that, I'm going to talk about some scenarios that you may want to consider use RTK over the regular GNSS positioning mode, and also talk about some required components for RTK drone operations. And because we have so many different methods for connecting the RTK service, so I'll be covering these methods as well. And at the end of this episode, I would also cover the connectivity quality and how that would affect the data accuracy and data quality, and then talk about some frequently asked questions and some troubleshooting strategies. All right, let's get started. Now let's talk about the standard GNSS positioning. In this method, a drone receives signals from satellites that are orbiting the Earth, and these signals are crucial as they help determine the location of the drone as well as the data collected from the drone. However, it is important to note that there are several factors that can interfere with these signals during the drone operation. These could be atmospheric conditions, buildings, or even tree cover. Such interferences can lead to slight inaccuracies in the location data and cause the drone data to be inaccurate. In terms of the data accuracy, with the GNSS positioning, it typically range from 2 to 20 meters, and this means while the GNSS positioning is quite efficient, it does have margin of error due to the factors that we mentioned earlier. You may have experienced using your phone for navigation and having the position of yourself drifted for a couple of yards, and that is because you're experiencing interference. Let's now discuss the RTK, or real-time kinematic positioning method. RTK is a sophisticated satellite positioning system that not only uses GNSS orbiting satellites for positioning, but also uses an additional ground station for a secondary position reference to enhance positioning accuracy. This secondary position reference is critical to provide high precision data. The ground station corrects the signal errors caused by atmospheric disturbances, satellite clock errors, and other interferences. This allows RTK to provide positioning data with accuracy up to a centimeter level. It's commonly used in applications that requires high precision, such as land surveying and autonomous vehicle navigation. Surveyors usually establish these ground stations for position reference based on a geographic known point monument or a point accurately measured with professional GNSS equipment down to the centimeter level. For instance, on the right side of the screen, I have a blue circle that indicates the GNSS positioning accuracy range, which again is 2 to 20 meters. And in the middle of the blue circle, I have the red dot there to indicate the RTK positioning accuracy range, which is only 1 to 5 centimeters in radius. As you can see, just a few pixels there compared to the blue circle we have there. Having explored the two positioning modes, we will now discuss the benefit of using RTK and situations where you may prefer it over GNSS. Firstly, RTK offers more accurate data collection, making it ideal for surveying and other tasks required high precision. Secondly, it improves the drone's hovering accuracy, allowing for easy comparison of data collected over time from the same location. Lastly, the high-precision hovering capability facilitates the design of autonomous waypoint missions around obstacles. This enables the drone to accomplish tasks not possible before in GNSS mode, such as autonomous close-up, facade photo capturing, and detailed waypoint inspection mission within substation, for example, when there are many nearby obstacles. Next, we will discuss the key components needed for RTK operation. Firstly, an RTK-compatible drone with an RTK antenna is required. Secondly, you need an RTK source which can be accessed through a network or a physical base station. Fortunately, all DJI Enterprise drones are RTK-ready systems. They either came with built-in RTK antennas or have the capability to attach one, which makes them all suitable for RTK operations. In addition, DJI Enterprise offers the DRTK series mobile station as an option to be used as RTK reference source. In addition to Enterprise drones, it's worth mentioning that the DJI Dock series also features an RTK-ready system. The dock itself acts as an RTK base station, and the drone inside is equipped with an RTK module, which includes a built-in RTK antenna. Once the dock is configured and set up, all data captured from the dock drone is accurate to the centimeter level. Next, let's discuss the various methods for connecting DJI Enterprise drones to the RTK service, each with its own pros and cons. And these methods include network RTK, non-DJI third-party RTK base station, and DJI DRTK series mobile station. Let's start with network RTK, which also happens to be the most popular type of connectivity for accessing RTK service. The major advantage is that network RTK eliminates the requirement and the setup process for additional RTK base station. As long as you have public internet access around your operation site and a nearby base station within that RTK network, you're ready to go. You don't actually need to bring additional gears other than your RTK supported drone. However, network RTK also have its cons. The biggest con, also happen to be the biggest pro of network RTK, is the internet connectivity type. You will have to connect to public network or internet to obtain RTK service. However, some operation area may not have reception at all for you to get access to internet from. In that scenario, you just cannot use network RTK. And in some area, you may have some reception, but the network is unstable. And as we all know now, RTK is happening in real time. When you have unstable internet, your RTK is unstable as well. This would result in inaccurate data. And second biggest con is depends on your operation area. Even when you have internet access, you may not have a close by base station within that network to reference from. This is the baseline we're referencing from. The baseline is simply the distance from your drone to the nearby base station. And let's say if that distance is too far away, the data accuracy can be reduced and be affected. Generally, we recommend to have the baseline within 10 kilometers, which is around 6 miles. So on the right side, I have a base station that is within a network service, and as you can see, it is 5.53 miles away from my operation site, which is okay. However, you may not always have a nearby base station that close to you within that network. So overall, which scenario would be suitable for using network RTK? First, the operation site has cellular connectivity or network connectivity, and it also has a nearby base station within that network service to reference the drone from. So that is the network RTK. Okay, before I move on to the next RTK connectivity method, I do want to spend some time here talking about the standard of the network RTK connectivity and the network protocol we use to establish a connection with third-party RTK networks. We use NTRIP. NTRIP is commonly used for streaming differential GNSS data, that is the RTCM file, over the internet. It allows drones to connect to an RTK network for precise positioning. This protocol is compatible with most third-party RTK networks, making it a versatile and efficient solution for RTK drone operations. However, it is important to ensure that the network provider supports this NTRIP protocol to guarantee seamless data transmission. So to configure the NTRIP, you actually need to input some settings. So on the right side, I have a screenshot from the DJI Pilot 2 application. And as you can see, you need to input the NTRIP configuration there to establish the connection with network RTK. One thing to be mentioned that is DJI Enterprise RTK drones are compatible with these following RTCM message types. So RTCM 3.0, 3.1, 3.2, and the latest 3.3 so far. So theoretically, if the third-party network RTK system that uses the NTRIP protocol also are transmitting these RTCM message types, they are going to be supported with DJI Enterprise drones. Next, you might be wondering where to find a network service. In the United States, you might want to start with the continuous operating reference stations, or in short, CORS network. CORS is a cooperative initiative that involves government, academic, and private organizations. The network provides base stations in support of positioning, meteorology, space weather, and geophysical applications throughout the United States. And in the United States, CORS are usually owned by state and managed by the local Department of Transportation. These state-owned CORS network can broadcast RTCM via the NTRIP protocol that we covered, which can be used directly for RTK drone operations. Now, it depends on where you live and where your project is located. The cost of the state CORS network varies based on states. Some states offer the service for free, like New York and Florida, while other states charge annual fees for the NTRIP service, like Texas. So whether you can use the CORS network or not, that really depends on where your project is located. Because in some states, you may not have a good coverage at all. Because we also need to consider the baseline, which is the distance from the drone to the closest base station within the network. If the baseline is too far, that would affect your drone data accuracy. So that is the CORS network within the United States. Okay, now let's talk about the second RTK connectivity method, which is the third-party RTK base station. Same like the network RTK, it has its pros and its cons. The pros is it does not require internet access. You don't actually have to have a reception at your operation site. And the coverage is theoretically global because it is not limited from the network coverage. However, the third-party base station also have its cons. First of all, it is a base station that you need to carry with you to the operation site and establish the connection between the base station and the RTK drone. You need to make sure constantly monitoring the base station, make sure it's constantly working, and you have to make sure to set up the tripod properly so it doesn't get moved. And for connecting the third-party RTK base station is also using the NTRIP protocol, which most base station will broadcast a local Wi-Fi network for you to connect from. And because the connection is through Wi-Fi, which is broadcast from the base station, the operation range can be very short. This is because you have to keep your remote controller connected to the third-party base station from the same Wi-Fi network. So that means you have to keep close to the third-party base station while operating the drone. This wouldn't be an issue if the operation site is small and you only have to fly the drone at one location. However, when you need to fly the drone at multiple locations, this means you have to get to a different location, repeat the entire setup process for the base station at the new location for multiple flights. and that could be annoying and increase the amount of a chance for having error caused by human. Another con is you will have to set up the base station on a known point for georeference. Otherwise, you're just going to receive drone data that is not globally accurate. So that is the third-party base station connectivity methods. As you can see, it has its pros and cons, but it does eliminate the need for having internet access and expand the operation range. So now you can do RTK operation anywhere you want. So the suitable operation scenario would be the operation site that have no internet connectivity and the operation site is huge. Also, the operation site happen to have a known point for the third-party base station to be set up on for reference. And the last RTK connectivity methods I like to go through is going to be the DJI DRTK series mobile station. Let's look at its pros and cons. Similar to the third-party base station, it does not require the internet, which is also suitable for global operation because there's no limitation on the network service. And compared with the third-party base station, DJI RTK series mobile station actually utilize the DJI OcuSync transmission technology instead of Wi-Fi to communicate with remote controller and drone. So this offering the operation range up to 7 miles. And this means the drone pilot doesn't have to stick close to the base station anymore and can work around and accomplish large operation sites without re-establish the base station from the scratch. And compared to third-party base station, it is extremely easy to set up the DRTK mobile station directly. And let's have a look at its cons. Similar to the third-party base station, it is going to be something extra you need to carry along with your RTK drone. And it does require setup before the operation. And just like the third-party base station, you do need to set the base station over a known point for accurate geo-positioning and obtain centimeter level global accuracy. With that being said, that's the 3 connectivity methods for DJI RTK drones to obtain the RTK service from. Finally, we will discuss the importance of RTK connectivity quality. This is crucial since RTK connections happen in real time, and the stability of RTK connectivity can significantly influence data accuracy. Signal interference and unstable internet can affect RTK connectivity. Suppose you have completed an RTK mission and captured all the data you want, only too late to find out that it was captured during unstable RTK connectivity. And this means you will have to revisit the site and recapture the data. So to prevent this, DJI Pilot 2 application includes a mission RTK quality report. This report displays the total duration of your RTK mission and the duration of the fixed status, indicating the stable and reliable connectivity duration. If the pilot notices the data was captured during an unstable RTK connection, they can immediately refly the mission. Furthermore, the DJI Terra software's quality report features an RTK status section showing whether the imported data was captured under reliable RTK conditions or not. Let's have a look at some frequently asked questions about RTK. First question we have is, what RTCM message formats does the DJI Enterprise drone support? The answer is format 3.0, 3.1, 3.2, and 3.3. The second question we have is, after using RTK base station for my drone operations and I found a large horizontal XY arrow, what could be causing this? Very likely you are not setting the base station over a known coordinate, because RTK provides enhanced relative position. However, if the referencing source, which in this case your base station, is not tied down to the known coordinate, then it is going to give you that consistent XY arrow. However, if your XY arrow is inconsistent compared to multiple known points, then this might indicate that you have poor RTK connectivity status. Next question is, after using RTK base station for my drone operation, I found a large elevation arrow. What could be causing this? And the answer for this one is, the arrow could be due to not accounting the base station rod height. You need to offset the rod height when setting up on a known point. And last question I have is, why is it hard to fix my drone's position? So when connect the RTK service to the drone, sometimes it's hard for the drone to get into the fixed status. So when that happens, it's usually due to obstacle around the drone. So one quick trick to solve this is disable the RTK connection first, ascend the drone to open sky that have no obstacle on the horizontal level, then re-enable the RTK option. That should help to get the RTK status to fix quicker. All right, so that's all the frequently asked questions, and that's the end of this episode. If you have any questions, please feel free to reach out to us, and I will see you in the next episode.